Hello, Professor. Our project is about the simulation of the customer service and support activities at the Lamar University IT Services Help Desk. I'm Vishnu Mahesh, and these are my friends and team.
I'm Adedapo, Ilori.
Hello, I'm Acyut, Kaneria.
So here is the goal of our project. We have created a simulation to model the customer service activities at the IT help desk, and the IT help desk is responsible for dealing with and solving all the technical issues related to the computers and basically everything from login issues to the technical systems breakdown on campus. So we have basically built a model of the university's IT desk to model the customer request calls and the formation of the queues, and we have created animation and plots for the model, and finally we have gone into the analysis of our simulation, and we made our views and discussed about we have given a discussion about the improvement of the resource utilization and to shorten the queues, and we have also offered our suggestions to improve the model. So the Lamar University's IT help desk stays pretty busy, and it serves an average of about 600 customers a day, and the service request comes in the form of customer walk-ins or customer requests through phone calls, and it can be to place work order for any systems breakdown, or it can be for simple issues like login problems or PIN or password resets. You can say that it is a window to the organization, and in this model we have created a discrete event simulation.
So what did we do? We carried out time study on activities going on in the service desk. We took data of the phone calls, walk-ins, emails, and we also got data from the service desk. They were happy enough to provide us with some data, and we have to mention the fact that we took all this. We used a single day of the week, which is Monday, and that happens to be the busiest day in the service desk. So our model is based on a Monday of the week, and we did our data analysis. We used the input analyzer to get an exponential distribution, and what happened with that was the fact that our model kept on giving us results which didn't really conform with the actual output from the service desk. So in order to counter that, we realized the fact that there's a huge difference in the certain period of time of the day in the service desk. For instance, between 12 and 1 in the afternoon and between 11 to 12 midnight, the difference between those times is considerably significant. So we decided to use a non-stationary pause on process arrival schedule. We modeled this with the Arena software, which was taught extensively in the class. And for this, we will take you to our Arena software to see what our model looks like. If you look to the left pane, we have defined 3 different views. We have the model, which shows all our flowcharts, and we have 3 different entities coming in. We have entities coming in via telephone, we have entities coming in via walk-in, and then we have email entities. We have to, if we take you to a spreadsheet module of the resources, you will see that we have 7 resources, and all of them actually deal with all of these entities that come in, and we have a set. We defined a set for which entity can handle which resource rather can handle which particular entity. And there's also an extra resource which happens to be the trunk line. The Lamar service desk has 35 trunk lines. We have a seize module that seizes the trunk line, and we have a release trunk line module at the end as well. So if we take you back to our views, you can see we've also animated our model. We have the trunk line and we have all the resources, and we have also created plots for each resource to display their utilization. We have imputed the graphs of each of these, the plots of each of these resources into our final report, which you will get to see hopefully. So let's take you back to our presentation.
This is the result which we got after the simulation of the service desk, and there were 10 replications carried out, and the number out was 624. So the average waiting time of each of the processes over there are as given below. The operator calls 10 minutes, the password reset 15 minutes, PIN reset is around 15 minutes, emails are around 11 minutes, walk-ins is around 22 minutes, and work order is around 16 minutes. And this is the results of the resources as compared to the utilization and the number seized. As we can see that the Eric is the less utilized among the all, but the number seized means the number of calls answered by him is the maximum, as he needs to just receive the calls and transfer it over to the required department. And Chantry is the next least from Eric in order as the number seized, and she is the most utilized among the all of them. This is the counter statistics of the results which we got after the simulation. The completed calls, emails, recording, walk-ins, and the rejected calls. All are being listed over here.
So here are some challenges that we had to face while we developed this model. First of all, the simulation is carried out for normal weekdays. We did not account for the weekends, as the distribution is quite different from what we have on normal working days. And secondly, we really did not have a means to determine the actual queue that is formed over the trunk lines, so we had to rely on the data that is provided by the service desk. And here, contrary to usual, where usually the customers walk up to the receptionist or walk up to the resources, here the operators actually go to meet the customers whose complaints need to be addressed. So we did not have a means to do this in Arena, and so we believe we have tried our best to model this using the stations and routing. So while it takes around 30 seconds, close to 30 seconds for the operators to walk up to meet the customers, and we have modeled that also.
So in conclusion, if you look at our results, what we noticed is that it actually came to close comparison with the live data that were made available to us by the service desk. So we think our model actually closely describes the activities that go on in the service desk on a busy Monday. Also, results from the crystal reports, as you have seen in one of the previous slides, show that Eric is the most seized of all the resources, but at the same time he happens to be the least utilized. So we suggest that training Eric to handle other types of call would improve activities and it will reduce waiting times, especially walking queues, which we can see is actually the walking queue lasts for about the average for about 22 minutes. Gentry and Andre happen to be the most seized, and Gentry happens to be the most utilized. We also we found out that the reason for this is because Gentry and Andre happen to work at the peak period of the day, and as compared to all of the resources that work at times that are not so busy as they do. So we believe that a better scheduling could help improve these hours of the day. So this is our presentation for this project. Any questions or comments can either be emailed to us or posted in the discussion boards on Blackboard. Thank you very much.
Thank you.